Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey, physics students, today we are going to start level 4 quest guide. We don't have a problem here. We're going to talk about motion in 2 dimensions. Now, when we're doing this, it all starts with vectors. Vectors are the key. Now, we've learned a little bit about vector. So why do we use vectors? Why are vectors important? They are important because they allow us to model situations in multiple dimensions. What we're talking about really when it all comes down to is there will be an X and a Y, right? Oops, oh, X here and a Y here. And what we can do is we can draw a vector here and a vector here, but usually we've got some kind of an angled thing going on, and that helps us to solve so many things. That's sort of an X and a Y. So let's talk about how we can draw vectors. I think the very first step that you want to do, step number 1, is you want to draw a compass, all right? An X and a Y, like we have right here, okay? The second thing is you always start at the center. So that'll be right here. We'll do a couple examples here in just a minute. And then you want to measure, number 3, measure the correct angle. Now, if we were doing this with like graph paper, you'd probably use a protractor. We're going to usually sketch it. You're going to see how we do that. And then you're going to draw a straight line, step 4. And again, if we're trying to do this completely graphically, then we're going to measure with a ruler. And then we'll finish with an arrow. So that's what we do when we have vectors. So let's take a look at some examples down here. So draw and label the line flowing vectors where A is 3.1 centimeters to the north. Now if I had a ruler, then we would just start at the center, right? On the compass, draw, and I would go up here, and that would be, if you will, the vector A, arrow, right? Now B is 1.9 centimeters to the southeast. So if this is south, this is east, this is west, and of course this is north. So I'm going to draw this 1.9, boom, a little shorter than the other. Right, so that would be B, right? And then C is 1.5 centimeters to the northwest. So northwest, and it got a particular angle, 20 degrees, so I could go like that. And I'm not drawing the angles, but I would then, with the protractor, make that at 20 degrees. Do you see this? Letter D is 2.8 centimeters 30 degrees west of south. So if this is south, west of south, that means that this angle here, right here, is 30 degrees. So this is going to be D. E is 3.5 centimeters to the northwest. Now as a note, we had a northwest one somewhere or other. Maybe? No, we didn't. So to the northwest, so if it just says northwest, that's going to be at a 45-degree angle, and that would be this one, a little longer. And F is 1 centimeter, 40 degrees to the east. So 40 degrees, north 40, east. I'm not sure where that is. Whether it's going to be somewhere over here, and I'm not sure which angle is 40 degrees. When you do our physics problems, it'll be pretty obvious. Almost always, frankly, guys, what we're going to do is we're going to have, you know, the axis, and it's almost always just going to be quadrant number 1, if you will, here. And we're going to be shooting something off to the right, and we're going to know, this is projectile motion, we'll know what this angle is, and then we can do some math on it. Because ultimately what we're going to do is, we're going to talk about this, we're going to resolve the vector, and we'll talk more about what that means. We're going to actually figure out what the y value is and what the x value is by using some simple trigonometry. Remember, SOHCAHTOA. That'll be very friendly as we do these problems. So that's just a short introduction to this whole section on what the heck's a vector and why do we use it. We'll see you in class.
Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.